Okay guys, so sorry about the part 1 and part 2, but we had some video problems. So I'm going to pick up where I left off, where the video kind of cut off. We're going to talk a little bit about electron dot structures, okay? So when you have the halogens, they form single covalent bonds. So what we're going to be doing in this next part is we're going to be looking at covalent bonding, kind of like we did with ionic bonding. Now, when we deal with covalent bonding, we're going to be dealing with certain elements, okay? So what you're going to be doing in covalent bonding is for a single covalent bond, say for example you got column 17, which are all your halogens. So if I have fluorine, okay, and I mix fluorine, say, with another fluorine like I have over here, and I look at the number of valence electrons, each fluorine has 7 valence electrons, which means each fluorine can only share 1, right? Because they need 8. So each one of these fluorines need a total of 8 electrons. So what happens is they are going to share an electron between them. And these electrons travel back and forth across this bond, okay? So what you would do is, this is the showing of the shared pair of electrons, and then if you actually drew it out, we would draw it out like this. And this right here is a single covalent bond, okay? What if I had something where I had multiple elements? So say I had something like CH4, okay, which is methane, okay? So if I had the formula CH4, what that means is I have 1 carbon with 4 hydrogens around it. The first element listed, unless it's hydrogen, is always going to be the central element. So there are some times where hydrogen will be listed first, but hydrogen can never be the central element, because remember, hydrogen can only share 1 electron. So anytime we have a molecular formula and we're trying to show the bonding, okay, if it's going to be single, double, triple covalent bonds, we have to figure out what our central element is. The central element is usually going to be the singular one that's listed first, except for hydrogen. So watch, so I'm going to take carbon and I'm going to put carbon in the center, just like that, okay? Now, when I do this, I'm going to place 4 hydrogens around the carbon, like so. All right? These are single covalent bonds, meaning 1 bond. Now, there might be more than 1 bond total, but between 2 elements, it's going to be a singular bond, meaning 1 electron is being contributed from each one of the elements, okay? And they're sharing between them. So the total number of electrons between them will be 2, but each element is contributing 1 electron. So each hydrogen has 1 valence electron. If you go and find carbon, carbon has 4. So carbon is going to have 4 valence electrons, like so. Now, each hydrogen can only share 1 electron and receive 1 electron, because remember, they're moving over to helium, which can only have 2. Now carbon here has 4. So how many does it need to make 8? That's right, it needs 4 electrons to make 8. So what happens is each electron from carbon is going to share with 1 hydrogen here, 1 hydrogen here, 1 here, and 1 here. Okay, so as you can see, they're going to be traveling along these bonds. So they are sharing electrons between each other. So now when I write the structure for methane, I'm going to write it like this. And as you can see, 1 line represents 1 circle, meaning each single covalent bond contains 2 electrons. So in this circle, in this sharing, it's always going to be 2 electrons. So every covalent bond has a total of 2 electrons. Okay? Now, so 2 atoms held together by sharing a pair of electrons are joined by a single covalent bond. Okay? And there's some examples. There's fluorine, and fluorine, like I showed you earlier, has that single covalent bond. Now, a pair of valence electrons that is not shared between atoms is called an unshared pair, also known as a lone pair or a non-bonding pair. For example, if I have water, water we know is H2O, meaning it has two hydrogens bonded to an oxygen. Remember, I just told you earlier that each hydrogen can only share one electron. Oxygen has a total of 6 electrons, so it needs 2 electrons to make 8. So what's going to happen is it's going to share an electron with each one of the hydrogens, giving it 2 so that it has 8, and each one of these hydrogens is going to have 2 electrons. So you're going to have a single bond between the hydrogens. So these extra electrons that are kind of sitting out here on the oxygen are called unbonding pairs of electrons or lone pairs of electrons. Now, why is this important to note? Well, we're not going to really talk about the structure of the shapes or anything of these covalent molecules, but they do have set shapes. And part of how their shape is determined is by these lone pairs of electrons. Like I said before, we're not going to get into that in this class. If you took pre-AP or AP, they would get more into the structure and how the non-bonding pairs would affect the shape of the actual molecule, okay? Now, ammonia, same thing. Ammonia has 5 valence electrons. Ammonia is going to bond to 3 hydrogens, okay? So what happens is each hydrogen is going to contribute 1 electron. Nitrogen has 5 electrons, so it needs 3 to make 8. So it's going to share 1 with each hydrogen, giving the nitrogen 8, and each individual hydrogen will have 2 electrons. Remember, each line is considered a single covalent bond. Each line can only have 2 electrons, okay? And then methane has no unshared pairs of electrons, which is what we saw a minute ago when I drew the methane out for you. There's no unshared pairs of electrons there. All right, now we're going to move into double and triple covalent bonds, okay? So atoms form double or triple covalent bonds if they can attain a noble gas structure by sharing 2 pairs or 3 pairs of electrons, okay? A bond that involves 2 shared pairs of electrons is called a double covalent bond, and a bond formed by sharing 3 pairs of electrons is called a triple covalent bond, okay? So let's look at some examples of those. So if we're looking at oxygen, okay, so I'm going to move over here and erase what I had a minute ago, and we're going to talk about oxygen, okay? Now, so if I have oxygen that we breathe every day, so that means it's O2, so that means I have 2 oxygens here. Each oxygen contains 6 electrons, okay? So I'm going to put 6 dots around the oxygens, okay? Now, how many does it need to make 8, okay? Think about it. It has 6, so it needs 2 electrons to make 8. Each oxygen needs 2 electrons, so they're going to share between them so that they both get 8 electrons. Now, they have to share how many? 2, because they need 2 electrons. So I'm going to draw a circle here, and I'm going to draw a circle here, which means it's sharing 2 electrons per circle, okay? Now, let's draw this in bond form. 1, 2, and O. This represents a double covalent bond because each oxygen needed 2 electrons in order for it to be complete, to have the complete octet, which is 8. So this is called a double covalent bond. Now, what if we wanted to have a single covalent, or excuse me, a triple covalent bond? Okay? So a triple covalent bond, let's look at nitrogen, N2. N2 has 2 nitrogens, but nitrogen only has 5 valence electrons. okay? So if you only have 5 valence electrons, they're going to share 1, 2, and 3, okay? Because each nitrogen needs 3 electrons. So if each nitrogen needs 3 electrons, then they have to share a total of 3 bonds, okay? Because you're going to share between them. They're going to travel back and forth across the bond. So now when I write nitrogen, I'm going to write it with 3 lines, meaning each nitrogen's getting 3 electrons, okay? Now, here's a chart that we're looking at right here. So this is just some examples. See, these are all of your halogens right here that have single covalent bonds. Nitrogen has 3 covalent bonds, okay? Now, carbon dioxide is a gas. Carbon dioxide gas is soluble in water and is used to carbonate many beverages. A carbon dioxide molecule has 2 carbon-oxygen double bonds, okay? Which looks like this. Now, what you see here is CO2, right? Carbon with 2 oxygens. Remember, the element listed first is always going to be your central element, except for hydrogen. So here, carbon is going to be in the center, and you're going to have an oxygen on each side. Carbon has 4, and each oxygen has 6. So when this forms a bond, carbon has to have 4 more electrons. Each oxygen can only contain 2. So they're going to share 2 here and 2 here. So that's where the double bond on each carbon comes into play. All right, so that's it for today in terms of your notes. Now, there is going to be a sheet that you're going to work on, but I am going to have a second video where I'm going to do some example problems, and I'm going to help you understand how to do the worksheet in the next video, okay? I hope you guys have a good day, and good luck on your worksheet. See you later.